Module 6, Section 6, Objective 5. We're going to calculate the circumference of a circle. Okay, the circumference of a circle is just the outside of a circle. We would call it the perimeter of a circle. However, perimeter means straight lines. Circumference is curved lines. Okay, let's get some definitions here. Okay, so a circle is all points that are the same distance away from a center point. What does that mean, right? Okay, let's take a look at this first circle. Can you see how that could look like a bike tire, right? And all of these, I'm going to erase all of this, but these would be the spokes of your tire, right? Okay, each of these spokes is the same size. Every single one of them are identical. I don't know if you've ever had to replace spokes on a bicycle tire before, but you tell them what the size of the tire is, and they give you a spoke, and you can put it here, you can put it here, you can put it here, it doesn't matter. They're all the same distance away from the center to this outside. Okay? So the same distance away, you will hear me say possibly equidistant. That means the same thing. Okay, so let's clean this up a little bit. All right, so the circle is all points that are the same distance away from a center point. So when you get into geometry, if you ever do, the circle is labeled by its center. Okay, so this would be the center, and that would be A, so that would be circle A. Okay, capital letters usually denote that. Small letters are usually distances, so that's what the R here represents. R is the radius. The radius is the distance from the center point to any point on the circle. So that's like what I just drew, right? That was all of the spokes that I had drawn in. Okay, so I'm going to put that over here. Spokes. And I'm going to tell you one more thing that it looks like. If this was the sun, these are the rays of the sun going out, right? Okay, really messy and shaky, I apologize. So we're going to call those rays. They're technically not, but you get the idea. It's the rays that go out. Okay, so this goes center out, like the sun. Okay, so that's how you can remember the difference between radius and diameter. Okay, so the rays go out of the center, just like sun's rays do, or they're the spokes of a tire. I know I'm repeating myself. Okay, the diameter is the distance across the circle through the center. If you notice, we have a ray here and a ray here, two radius. Plural of radius, by the way, is radii. And I hate saying that, so I usually say radiuses, and I know that's wrong. But you have two radiuses back to back to make the diameter, sorry. So the diameter goes straight through the middle. Okay? Can there be more than one diameter? Absolutely. You could go all the way across this way. That's a diameter. You could go all the way through this way. That's a diameter. And you can see it looks like spokes of a tire again. However, these are one straight piece. The spokes are individual pieces, right? Okay, so like I said, the diameter looks like two rays back to back. Okay, that's what this is telling you about over here. The diameter is twice the radius because we have one ray on this side and one ray on this side. So two radiuses, two radii. So that's where that comes in. Or you take half of the diameter. So if this is the diameter, but we only want half of it, you get a radius. Okay, so they are connected. using that box. Okay, the circumference is the distance all the way around a circle. And they put perimeter in there, but remember, perimeter is for straight sides and not for curved sides. Okay, so if I were to cut right here and open this circle out flat and measure it from one side to the other side, that would be the circumference. If I were to zoom all the way in here, I know this is kind of silly, but it'll make sense. If you had a little ant here that was going to run around the circle, how far would he have to run? Okay, it's going to be a single distance, right? Okay. Hopefully that page makes sense, and hopefully I didn't make you too dizzy. I apologize. Okay, now this page looks crazy, but it really isn't. So these are your two diagrams that you have from your last page, right? Okay, there's your formulas for the circumference of a circle. You have two of them depending on what you are given. If you're given the radius, like on that circle, you use that formula. If you're given the diameter, like on this circle, you can use that formula. Or you can understand that one diameter is equal to two radiuses, and you can use either one you want. I'll show you how to do that. Okay? Now the question you might be having is, what is this symbol? Okay? Some of you may already know it. That's a Greek letter pi. Okay? And you write it by doing like a little squiggle, a tilde, and then two legs. If you want to get really boring, you can put a straight line and two legs. But don't go crazy with your squiggle and then two legs. You will never see that. Okay? So the legs sometimes can get really fancy. It doesn't need to be. Okay? A lot of calculators have a pi button, but don't use it. And I will explain why here in a little bit. In fact, next. Okay? Pi is the irrational number that is approximated by 3.14 or 22/7. Okay? Where do they come up with these? 22/7, when you divide it, you get 3.142857. And then it continues. Okay? It doesn't go in evenly, it continues. That is pretty dang close to 3.14159, blah, 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 all of this, right? So 3.14, and then if I rounded this to a 2, it would be the same as this. That's really pretty small when you're doing some measuring, okay? If you're talking about miles, it would be different, but if you're talking about inches, you couldn't even tell the difference. However, this is a fraction. We're not going to worry about that because we're not in a fractions chapter, okay? We're in a decimals chapter. And so we're going to use 3.14 as the approximation of pi. This is what you usually see. And this is what you are going to be asked to use, okay? You're going to use 3.14 instead of the pi button on your calculator, because your pi button gives you that long red number, this one. And then it does your calculations with this whole thing. You're going to calculate with just using 3.14. It keeps your numbers shorter. It makes them so they don't repeat, or they're not going to repeat, because pi is irrational. It's non-repeating, non-terminating. So if you have to work with those numbers on your calculator on a regular basis, it's much harder. Okay, so we're just going to use 3.14 and leave it at that. Okay, let me slide it up a little bit. I'm sorry, I left that bottom one. Pi, the definition, is the numerical value of the ratio of the circumference of a circle to its diameter. Every single circle, no matter how big it is, has pi in the formula. It is the ratio of the circumference to its diameter. So all the way around, divided by its diameter, and you will get pi every time, no matter what size the circle is. It's kind of cool. All right, so let's go back to these two formulas. I'm going to write those down on the next page just so you don't have to keep looking in your notes or anything, and we're going to do a couple. All right, so here we go. Two formulas. We have, circumference is equal to 2 pi r, or circumference is equal to pi d. And if you notice, here's your d, and the diameter is 2 radiuses, right? Here's your 2 radiuses. Okay? So they are basically the same equation. They're just using different measurements. So if you're given the radius, like this one, I would choose to use this formula because it has the radius. If you're given the diameter, like this one, I would use the diameter, and it would make it very easy. Okay, I'll show you both, but let's start with these. Okay, so because it's radius, we're going to use 2 pi r. And we know that the radius is 5.2. So I'm going to substitute, and 2 comes down, and I'm going to times it by pi, which is 3.14. And it says right here, use 3.14 for pi. You're usually going to see that, like I said. And now the radius is 5.2. Okay, so now on your calculator, you can just type straight across because they are all multiply, and multiply is both associative and commutative. So 2 times 3.14 times 5.2. And you get 32.656, I believe, if I did that right. We'll pretend I did. 32.656. Let's double check, just do a quick estimate and see if it's possible. Okay, so this is about 3. This is about 5. So 3 times 5 is 15. Doubled is 30. And that's pretty close. I dropped down, and so this would be a little bit bigger. That's right. Okay, circumference. The label is just going to be a distance, so it's plain, inches. Okay, now what if I were to use the other formula? I would have to figure out what the diameter was. Okay, so the diameter is going to be 2 times the radius. Okay, so the radius is 5.2 times 2. So 10.4 is what I would use here. And when I multiply those two, I'm going to do 3.14 times 10.4, and I get exactly the same answer. Okay? And if you can hear my cat in the background, I apologize. He's getting kind of vocal. He wants to go outside, but it's raining. Okay, next one. So we have circumference is equal to, now this one is the diameter, right? So I'm going to use the diameter formula. Just because I know them both and I'm able to switch between both of them, no problem. It just makes life a little bit easier. However, I'll show you how to do it without. Okay, so pi is 3.14, like they said. And now the diameter is right there, 6.7. So calculator time, 3.14 times 6.7. And I get 21.038. It's circumference, so it's only a distance. You just leave the label plain. You don't put a squared or a cubed or anything on it. Okay. What if all I had memorized was 2 pi r? Okay, I don't know the radius, but I can figure it out because I can do 6.7 divided by 2, and I would get 3.35. So in my formula down here, I would use 3.35 instead of trying to get my colors done right here. Okay, so 6.7 is 2 times 3.35. Okay, so now on this one, you're just typing in more, and you had a little bit of work to do to get to this point. But if I do 2 times 3.14 times 3.35, I will get the 21. There we go, 21.038. Okay, so it doesn't matter which formula you use as long as you put the correct number in its place. Okay?